Hi everybody, it's Miss Austin. We're going to continue on here. Hopefully you've watched the first video for lesson 16, which was a review of completing the square, and the next video was 16.1. Now we're on to 16.2, different ways to solve. So before we even jump in, I just want to kind of do a side note over here. I mean, solving a quadratic, let's start with something super easy like that, right? We've been solving ones like this. When we see x squared set equal to a positive number, right? We know this potentially has two real solutions. What number can I square to make 25? I can square 5 and I can square -5. I could go to Desmos and look at a picture of this. When does x squared run into 25? There's my two answers, okay? The other way I could think about that is I could do the procedures behind it. Let's look at what those look like. X squared equals 25. To undo square, I square root. Whatever I do to one side, I do to the other. Because this started out as x squared, I know x could be the positive or the negative square root of 25, which is 5 and -5. I'm allowed to consider that -1 because I know it's being put in and being squared. Okay? Well, now look over here. We're going to start solving quadratics like this one up here. It says x squared plus 6x minus 7 equals 0. That is much different than x squared equals 25. Okay? They want me to figure out what numbers or number can I plug in for x that will make this equation equal to 0. Now, the problem is this was super easy because I just had x squared. So as long as x squared's alone, you undo it or think your way through it, you got it. This problem has an x squared and an x. There is no way to isolate the x's. So this is where these tools finally come in. So this 16.2 shows two different students who did the problem two different ways. We've got Elena, who did what we were just talking about, completing the square. And then we have Han, who does the quadratic formula. So I'm going to walk through this to make sure everybody understands. So see this problem right here? It says, Elena said, first I added 2 to each side. Now, why would she add a 2 over there? The reason is what we just did with the box. She was trying to make this problem a perfect square. She had x squared. If she cuts that in half, she gets -3 and -3, which if this was a 9, this problem would be able to be rewritten as x minus something squared. But it's not a 9. Shoot. Well, she's like, hey, I can manipulate this. I'm going to add a 2 over here. I'm going to turn this into a 9. You're allowed to do that as long as you do it to the other side. So now the book doesn't show this, but I want to show you this. We have x squared minus 6x plus 9 equals 2. Look at this left-hand side. Yay! That problem is now this box, a completed square, which can now be rewritten as x minus 3 times x minus 3 or x minus 3 squared. Now, why do we care about that? Because now look, we don't have x squared and x, we just have x. And it's being raised to the second power. Well, I can isolate that. Elena says she takes the square root of both sides, so she goes like this. And because this problem is something squared, you're going to consider the positive and the negative square root of 2. So the square root undoes the square. So now we have x minus 3 equals either the positive answer to the square root of 2 or the negative answer to the square root of 2. And then she adds 3 to both sides and she leaves it. So the two answers are 3 plus the square root of 2 and 3 minus the square root of 2. Why aren't we writing these as whole numbers? Well, go ahead, try it. The square root of 2 is an irrational number. It goes on forever and ever. So if it doesn't come out, we're leaving it as a radical. So that's what she says the two solutions are. Now, I will show you on Desmos, if you want to see if you're right, we can figure out what these are as decimals approximately and go check in a minute. So let's go look. 3 plus the square root of 2 is about 4.41. Now, you're not going to be allowed to write that as your answer, but we're going to use that as a checking mechanism. And then 3 minus the square root of 2, about 1.59. And we'll go do that in a minute. Okay? So Elena just solved this problem by completing the square. And I would write that right here. This is called completing the square. She forced this problem into being a complete square. It started out with a 7. She needed it to be a 9. So she added 2. Okay? Now we're going to look at the next page. The next page, Hans solved it. Now you haven't seen this in a while, but in Algebra 1, you were introduced to the quadratic formula. It's a formula that allows you to find the solutions to a quadratic. And it might seem like, well, I'm always going to use the quadratic formula. It's a lot of work, and there's a lot of spots that students make errors. So it's not always the easiest way. But let's break down what Han did. When you use the quadratic formula, you need these, look at the letters in here. You need an A, a B, and a C. A is the number right here in front of x squared. B is always the number in front of x. And then C is your constant. And you can't get those, okay? You have to make sure that this says 0 before you identify those 3 things. Then once you figure those out, you're just going to take those numbers and you're going to plug them into this formula right here. So this said to take the negative of b. Well, my b was negative, so the negative of a negative is positive. 6 plus or minus b squared. Negative 6 squared is 36. Minus 4, that's part of the formula, times a, which is 1, times c, which is 7, all over 2a. Okay? So first step is just getting everything plugged in right. Now, here's where students go wrong, and I'm going to tell you what I think is the easiest thing to do. You're going to now type this stuff right here into your calculator. Don't type the square root, just the numbers under it. Right? And then some students try to do in their head 36 minus 4 first and then multiply. No, you got to follow order of operations, right? So I'll just show you on a calculator. Just type that whole line in. Do not type the square root yet. 36 minus 4 times 1 times 7. 8. That's how they got this. Okay? 6 is still there, and then 2 times 1 is 2. Now, 8 does not have a whole number square root, so you're going to leave it. Okay, unless that's like the square root of 16 or 25 or 36, a number that has a whole number square root, we're leaving it. Okay, then how do you get to here? Both of these are being divided by 2. So look at them separately. What's 6 divided by 2? That's where he gets the 3. And even though you feel like it, you can't divide the square root of 8 by 2. You can't divide a radical by an integer. They're separate, okay? So that just stays the square root of 8 over 2. And then he separates his 2 answers. He has 3 plus the square root of 8 over 2. See that one? And 3 minus the square root of 8 over 2. There's that one. And then we're like, wait a sec, that's the same problem? That doesn't look like Elena's answers. How come? Because he did it a different way, and it's simplified different. But watch what happens. I'm going to type this into my calculator. Watch. The square root of 8 divided by 2 plus 3. I did this part first, and then I added 3. That says that is approximately, oh, I did something wrong. 4.41. That's the same as Elena on the other side. Now let's do this one. I have negative square root of 8 divided by 2, negative square root of 8 divided by 2 plus 3 in the front. 1.59, same as Elena. These answers are the same even though they look slightly different. The reason is that can actually be cleaned up a little bit, but we're not worried about it. If you do the quadratic formula and you get your answers to here, you're good. If you use, oh, now I lost the piece of paper. Oh, no, I did. If you use completing the square and you get your answers to this, you're good. Now, why would I want to use the decimals? Because I would maybe want to go to Desmos and go check. Let's go check, especially if you're on a quiz. Where's your mouse, Miss Austin? Hang on, guys. I'm going to go get my Desmos. Hopefully you can keep seeing this. Desmos.com. And we're going to go look at this. Now, in the past, you've been able to use Desmos to solve. This problem you wouldn't be able to because it's not going to give you those exact answers. So we're just using it to check. When does x squared plus 6x, or minus 6x, plus 7, when does that equal 0? That's right here. Look, now let's see if those answers are what we got. About 1.59, we rounded a little bit sooner, and 4.41. Yes. Now you're not allowed to write those as your answers. You have to write your answers the way that Elena and Han did. You can either write them this way, 3 plus the square root of 2 and 3 minus the square root of 2. Or if you use the quadratic formula, you can say 3 plus the square root of 8 over 2 and 3 minus the square root of 8 over 2. Okay, this is the quadratic formula. And then Elena's was completing the square. So if you need to watch that video again to get an explanation and watch how I simplified and where I got all those numbers, I'd highly recommend watching it again. The next video is going to be 16.3, where we put all of these strategies to use and solve 6 different quadratics.